Alright, Trig day number 6, graphing and making sinusoids. Just a reminder of the 3 tricks in solving equations. Be familiar with those, especially number 3. Alright, I think I covered this one before. I'm going to jump into this one here. 2006, paper number 1. Paper number 1 is a no calculator paper. When solving this problem, I would most likely bring this term over to the left side and also go into my identity toolbox for that. So there's my identity there. I didn't go parentheses before, I won't start now. Alright, and I got it equal to 0. Next thing I would do is factor. Probably factor out just a cosine x. That leaves a 2 sine x minus root 2. Zero product property tells me that either this has to equal 0, which happens when x is pi over 2. Notice our restrictions up here, 0 to pi. So I won't go with 3 pi over 2. Or this right here has to equal 0, which would mean that sine x would equal root 2 over 2. That's going to yield me potentially a couple answers. Right, so I already know that x equals pi over 2 is an answer. This would yield me over here x equal to, I believe, pi over 4 and 3 pi over 4. So my answers would be x equals pi over 4, pi over 2, and 3 pi over 4. Of course, if that restriction is lifted, you got a couple more answers that might appear. Alright, let's continue with today's lesson. Okay, so here we've got a sinusoid and a bunch of important stuff. A here is the amplitude. It represents a vertical stretch or shrink. It could also, depending on if it's positive or negative, represent a vertical reflection. Okay, so A is the amplitude. B is going to equal it's going to have, how shall I say it, effects or can produce a different period length. So actually, let me go back and do this. 2 pi divided by b is the period of the function. Okay, C is the phase shift. Phase shift, that'll be a horizontal shift, either left or right. Let's say it were x minus, I don't know, pi over 4. That would represent a shift to the right, pi over 4. Okay, as we're going to see here in a moment. And D, of course, is the vertical shift. So positive it goes up, negative it goes down. Alright, the order in which I typically will graph these or work is I always work with B first. So I work with B, then C. These are my horizontal transformations. Then I work with A, and then I work with D. Alright, so let me just graph one period of the sine function, and then we'll graph this thing. Okay, so one period of the sine function typically has a length of 2 pi and would look like the following. So here is your sine function. Let's say that's 1 and negative 1. That's what our function would look like. So now let's do some manipulation. Alright, so let's work with b first. 2 pi divided by b, which is 2, is our new period. So now the length of this function is simply pi units, so it's going to oscillate twice as fast. Okay, I'm also going to work with C here for a moment. So first let me graph B. If we were to just have this transformation, right, just B, our function would look like this. Right, it's been shrunk horizontally. Okay. One way that I could represent that without redrawing it would be the following. Take each of these values, right, along the x-axis here and just rename them. So now instead of a period of 2 pi, we have a period of pi. That'd be pi over 2, pi over 4, 3 pi over 4. Now watch, I'm going to throw an extra pi over 4 interval up there, 5 pi over 4, because I'm about to do two things now. Right, this negative pi over 4 here, I should do that in a different color. How about black, like I did above? Minus pi over 4 tells me write pi over 4. So if I shrink the graph horizontally and then shift it to the right, pi over 4, it's now going to look like this. Nothing has happened vertically with the graph yet. Okay, so what do we do now? Well, we're going to stretch it. We're going to stretch it by a factor of, looks like 4. So everything that used to be a 1 and a negative 1 is now going to stretch all the way up to 4 and down to negative 4. Okay, so I take my current spot and I stretch it by a factor of 4. Okay. And then what do? Well, then I work with D last, which means I'm going to shift this up 1 unit. So that would take our 4s up to 5s, and our negative 4s up to negative 3s. That also shifts, I want you to be aware of this. This is what I call the baseline of this function. I'm going to be shifting that up to 1. So our final graph will be shifted up here, right, and only go down to a minimum of negative 3. So that green function there, that's our new translated function. Alright, so cosine, nothing different. Everything is the same. All transformations are the same, except the cosine function now starts and looks like that instead of the sine function, which starts at 0 and ends at 0. So let's do a little bit of manipulation. Let's see what b does to this function. 2 pi divided by a fourth is equal to the period, which is now going to be equal to 8 pi. Alright, is there a horizontal shift going on? Yes, there is. So we're going to take our function, we're going to shift it left. It looks like left pi over 2. Okay, so let's think. We've got b, then we've got c, and then we've got, looks like a, and nothing for d. Alright, so a is going to be times 3 and a vertical reflection. And D, there is no movement. So let's see if I can sketch this out. My baseline is going to stay at 0. It looks like my period is going to be stretched out to 8 pi units. So I'm going to go here. This will be 8 pi units. That'll be 4 pi units. This will be 2 pi units. This will be 6 pi units. Okay? Now cosine, right? Instead of 1 and negative 1, I'm going to have 3 and negative 3. Now be aware that we're going to shift left pi over 2 units. Pi over 2 units is a very small shift, right? Because if this is 2 pi, then this is pi, then this right here is pi over 2 and 3 pi over 2. So it's a very small shift to the left. So our graph, if I wouldn't have had that shift, let's ignore that shift for a second, would have looked like this. Why is it upside down? Because of the negative in front of the 3. So I'm just going to take that and slightly shift it. to there. And that right there, folks, would be it. So I've got a nice little shift of pi over 2. Come on now. There we go. Right. Nice little transformation there. Okay, let's move on to tangent. So tangent is different than sine and cosine because the tangent's normal period is not like sine and cosine, which is 2 pi. It's actually pi. So this is still vertical reflection. This still has to do with the period. This still has to do with phase shift and vertical shift as well. However, this now for period is pi over b. Everything else stays the same. Tangent is undefined. At pi over 2 and negative pi over 2. Okay, so hence, right from here to here is pi units, which is a period. Okay, but we're about to change that real quick. So our period here is going to be pi over, looks like b is pi as well. So it's actually going to be 1. So these values won't be pi anymore. I want this length to be 1. So this is going to be 1/2 and negative 1/2. Okay, now tangent normally goes through 0, 0. Okay, it normally goes through 0, 0. However, in this case, that is a vertical shift down 1 unit. So I'm going to take that graph and shift it down 1 unit. Okay, and then the 2/3 piece, that's just a shrink. Okay, that's not going to be all that critical within your sketch, but you can imagine it's a little bit more shrunk to the x-axis. Okay, that's a vertical shrink by a factor of 2/3. You won't be required to specify like what point becomes, right? Right, how this point, when it's vertically compressed by a factor of 2/3, becomes this. Okay, that won't really be that critical. What is critical is where the shifts take place and the period length is. Alright, so take a moment here and see if you can identify what's going on with these 10 problems. And identify B in the first 4, and then identify the transformation that's taking place, either horizontal stretch, horizontal compression, vertical stretch, vertical compression, reflection, either horizontally or vertically, and so on. Okay, check your answers here. I want to highlight just a couple of these. In part D here in the first section, in order to get a period of 4, B would have to be pi over 2. So if I took 2 pi over pi over 2, the pi's would cancel. And when I divide by 1/2, that makes that 2 of 4. Okay, a couple other things I want to highlight. Let's see here. Here in part B of the second section in green, this is a horizontal stretch by a factor of 4. So when we work on the inside, right, this value 1/4 would be B, and it's just the opposite of what you'd think, right? 1/4 makes you think compression, but it's actually a stretch. And the last one I want to talk about is F. This is a horizontal reflection over the y-axis. All right, we got a vertical reflection in part C, that would be over the x-axis. This would be over the y-axis. All right, let's go ahead and graph a sinusoid real quick. So I'm going to put a general sketch up here, and we're going to build a sinusoid based on this. And what you want to do is you want to see if you can find maximum values. Right, so if I have a maximum there and there, I'm actually always going to build cosines using this. I would never build a sine function due to the fact that, right, if I have a maximum at t equals 4 of 13, and I've got another maximum at t equals 16, and it's also 13. Oops. then I know that I have a cosine function with a minimum somewhere in between. And in this case, it looks like my minimum is at t equals 10, 6 units from both of those, and my min value will be at 11. So that helps me to build this sinusoid, which is actually a cosine function. Alright, so let's talk a little bit about stuff here. First thing I identify is the vertical shift. Okay, so the function had to have shifted up, and to find the vertical shift d, we're going to take our max plus our min and divide by 2. So our max is 13, min is 11, divide by 2, we get 12. Now that might just be common sense there, but in some cases it's not so clear. Alright, the next thing I would identify would be c. Now c, for a cosine function, normally starts at 0. I would shift it to the right. It looks like 4 units. So I would have a 4 here. Okay, b. B is the distance from max to max, and that in this case is 12. So b is not 12. In order to get our period, remember period equals 2 pi divided by b. And we know in this case our period is 12 units, so we got a little bit of work to do. So it looks like we'd multiply by b on both sides, and then divide by 12. So b is pi over 6. And then a, let me go in a different color here. A will be our amplitude. Our amplitude is the distance from the baseline to either the max or to the min. So that distance is 1. Therefore, we can now write out our sinusoid. Again, what is this? Population in years, right? Per year, is it years? Yes, it is. A is 1. Remember, this is a cosine function. B is pi over 6. I like to nest that like that. T, recall that we're shifting to the right, so we would subtract 4, and then we would add 12. There's your cosine function. Now we could actually use this to predict if this sinusoidal relationship continues. We could plug in any t that we want and find out what the population would project to be at that time. Alright, last example. Some of the largest tides in the world are observed in Canada's Bay of Fundy. The difference between high and low tides is 14 meters, and the average time between high tides is 12.4 hours. Find a cosine model for the height of the tide h in terms of t. So we want a cosine model where we have a cosine of b t. We'll determine whether it's minus or plus for c, and then we have some value d. Okay, so if the high and low tides differ by 14 meters, and the difference between high tides is about 12 hours, we could do a basic version of this and say at time 0, let's say that the height of the high tide is 14, and at time 12.4, the height of the high tide is again 14. Okay, if the difference between the high and low tides is 14 meters, then at time 6.2, halfway in between, it would have to be 0. So let's say the low tide is 0. Let's say the two high tides are 14. So we can draw our cosine function. Not well. Let's try again. Okay, now we can draw ourselves and sketch out a function for that. So our baseline is going to be, looks like 7, right? 14 plus 0 divided by 2 would be 7. So that's our baseline. So that means we're going to add 7 on the end. That's our vertical shift. Let's go C. There is no horizontal shift, so I could just get rid of this piece altogether. Right, because cosine starts right there at t equals 0. at its maximum value. So C equals 0. We got some work to do for B. We want 2 pi divided by B to equal 12.4. So I think what I'll get, and you can check my work, is pi over 6.2. So pi over 6.2 is B. And A is going to also be 7. Alright, so that would be a function there for part A to model that. And it looks like part B we sketched 1 period. Alright, that is trig day number 6. See you next time.